Hey guys, so today we're going to talk about empirical and molecular formula. We should remember this from honors chemistry, so we're only going to spend one day on this where I teach the lesson and you do a worksheet on it, okay? So we are going to talk about, as I said, empirical versus molecular formula. Super important. It's used a lot in chemistry to identify substances. If we have a substance that we don't know, say it's like a calcium oxide, we could use this process, this math technique, in order to determine what the chemical formula of maybe this calcium oxide is. So empirical is the lowest number of ratios, and molecular is the highest number of ratios, or the molecular, it's a multiples of the empirical formula, I should say, okay? So I might have a molecular formula that is C6H6. Okay, so that might be the molecular formula. Well, the empirical formula is just the simplified version of that. So the empirical formula would just be CH, okay, CH, which isn't a compound that exists, but that would just be the empirical formula, the simplified version. If I had the molecular formula, we'll do a couple examples. I'll just put molecular up here, and then I'll put empirical right below it. Okay, so if I have a situation where it's like C6H12O6, okay, if that's the molecular formula, the empirical formula is just a simplified version of that, which is CH2O. All right, let's go ahead and say, what if H2O was the molecular formula? We can't reduce that anymore, okay? It's just the same. So the molecular and empirical formula are the same. That happens sometimes, okay? Sometimes the reduced version is the molecular formula as well. And let's do one more. C12H22O11. All right, C12H22O11. Can we reduce that anymore? No. Okay, so the empirical is just the same as well. I try to remember, sometimes people get confused which one's which. Empirical formula, E is first in the alphabet, so that's the lower version. This is how I remember it. Molecular starts with M, that's later in the alphabet, so it's got to be the bigger formula. Okay, that's how I remember it. I don't know. You'll come up with your own thing, or you'll just remember it because you're smart. Okay, determining the empirical formula. It is a mathematical process. Okay. We like to have everything in grams. They'll give us grams of each element in the compound, but sometimes they give us percentages. Okay, so if they give us percentages, which they do, we just assume the sample is out of 100 grams. Okay? So they might give us like 15% carbon, 45% hydrogen, and 40% oxygen. Okay, so I'll just say 15 grams carbon, 45 grams hydrogen, 40 grams of oxygen. Okay, so I'm just changing those percents to grams. Next thing we're going to do is change grams to moles. Okay, we should know how to do that. We just divide by the molar mass. 3 divide by smallest number of moles. Okay, which I'll just show in the example. And then last is make numbers whole. And you'll see what I mean by that. Okay, so we assume the sample is 100 grams if we're given percentages. Sometimes they just give us grams and we don't have to worry about it. 2, change grams to moles. 3, divide by the smallest amount of moles. Did I put smallest? The smallest amount of moles. The smallest amount of moles. And then make numbers whole. All right, so let's go ahead and let's do an example. I'm going to erase my rules. Sorry, guys. You could always pause the video and look at the rules if you need to. Okay, adipic acid contains 49.32% carbon, 43.84% oxygen, and 6.85% hydrogen. Determine empirical formula. Okay, so again, we're trying to determine that empirical formula, that reduced chemical formula. So again, rule number one, if they give us percentages, let's change those to grams. So I got 49.32% carbon. I'm just going to pretend that's out of a 100 gram sample and say that's grams of carbon instead. I'm going to do the same for oxygen. And I'm going to do the same for hydrogen as well. That's step one. Step two, we're going to get these guys to moles. Okay, so we divide by the molar mass of each element. Carbon's molar mass is 12. Our units are matching up, so this is nice. Oxygen is 16. And hydrogen is 1. So moles of carbon, I am going to end up with, I have it written down here, 4.107 moles of carbon. I got 6.7, oh sorry, I got 2.74 moles of oxygen, and I got 6.78 moles of hydrogen. Okay, so that was step 2. Step 2. Step 3 is we divide by the smallest number of moles. So we look at this, we got 2.74, we got 6.78, and we got 4.107. We divide by the smallest number, which is that oxygen, which is 2.74. I feel like a weatherman. I feel like I'd be a good weatherman now that I'm doing this all the time because I can point while looking at the camera. Just need some visualization of cold front moving in or something like that. I digress. Anyway, so we divide these and we get something like, let's see, we will get 1.5 here. We will get 1 here. And we will get 2.5 here. Okay? And then last thing, we got to make those numbers whole. Okay, and we make numbers whole by multiplying them in chemistry. Okay, we don't add 0.5, we multiply them. So I'm going to multiply this by 2 to get 3. I'm going to multiply this by 2 to get 2. I'm going to multiply this by 2 to get 5. If you multiply 1 by 2, you got to multiply them all by 2. And what do these numbers signify? Well, they tell me how many of each atom is in our empirical formula. So what it says is I got 3 carbons, 2 oxygens, and 5 hydrogens. So it's an acid, so it starts with an H, and then it usually goes carbon, and then oxygen. Whoops. And that is my adipic acid empirical formula. Okay, so it's just like that, nothing too crazy. Okay, so that's that. Sometimes they might just give you grams straight away, and then you could just skip step 1. All right, so be aware of that. Molecular formula. Let's talk about that. How are we going to do something in that nature? So what happens is that they'll give you a molecular mass. So you'll use the molar mass from the empirical formula, and you'll use the molecular mass to determine the molecular formula. Now let me explain this. So what if I added to this question the molecular formula, or the molecular mass, sorry, is, let me do some math in my head real real quick because I'm coming up with this on the fly. Is 219 grams per mole. What is the molecular formula? Okay, what is the molecular formula? So they might add this on there, okay? So what they give us is they give us the molar mass of the larger formula, the molecular formula. So what we got to do is we got to take the molar mass of the molecular formula and divide it by the molar mass of our empirical formula, okay? So again, this is our molecular formula, which is 219. And we're going to divide it by the empirical formula molar mass, which is 5 plus 12 times 3 is 36, plus 32 is, looks like 73. Okay, 73 grams per mole for that molar mass, for that empirical formula. So I take my molecular molar mass divided by my empirical formula molar mass, and I should get something like 3, okay? So I got that nice number 3. Well, what do I do with that number 3? I just multiply 3 into that empirical formula, okay? So 5 times 3 is 15, so now it's H15. 3 times 3 is 9, so it's C9. That looks like a G. It is a G. And then 2 times 3 is 6, so it's O6. So that's our molecular formula, okay? So again, it's just an extra step where we're taking the molecular mass divided by the empirical formula molar mass, and that tells us what to multiply our empirical formula by, okay? Let's go ahead and let's do one more molecular mass example, and then I'm done. Sometimes when you get to this step right here, when you divide by the smallest amount of moles, sometimes you get a whole number and you won't have to do step 4. So be aware that step 4 might not be necessary. Okay, last example. Let's say the empirical formula for, let's say, adipic acid again. Actually, let me switch it up. The empirical formula for sulfuric acid is 196, is H2SO4 with a molecular mass of 196 grams per mole. What is the molecular formula? So here we don't have to find the empirical formula. They already gave it to us. Okay, they gave us H2SO4. Okay, so now what we're doing is just trying to figure out that molecular formula. So again, molecular formula, to figure that out, we take molecular mass divided by empirical formula, molar mass. Okay. Well, molecular mass they'll always give you, it's 196, divided by the molar mass of our empirical formula, which is H2SO4. Hydrogen is 2, sulfur is 32, oxygen is 64 for a total of 98. Okay, so 96 divided by 98 is 2, and that's how many I multiply into my empirical formula. So H2SO4 times 2 will be H4S2O8. So that is my molecular formula. Okay, make sure that you're going through the practice, going through the worksheet, making sure you're getting good practice with this. Okay, remember, if it's a percentage, change it to grams. Sometimes I'll just give it to you grams automatically. Change those grams to moles, divide by the smallest amount of moles, And then if they aren't already whole numbers, make them whole numbers. Okay? Have a good day, guys.